Okay, I also have the pleasure of introducing Divya and Zach, who are co-founders of Hotdata. Divya has been an awesome member of the DataFusion community. She's organized a ton of meetups in San Francisco. We're very fortunate to co-host this meetup with her. And yeah, super excited to learn more about DataFusion and DuckLake. So thank you.
Do you have the clicker with you? Ankush, do you have the clicker?
Oh, yeah, sorry. There you go.
Thank you. Hello, everyone. I'm Divya Ranganathan, and this is Zach Farrell. We are co-founders of Hotdata. We chose to build Hotdata on DataFusion, but in our former roles, we were early adopters of DuckDB. In fact, we adopted it as early as version 0.2. And built multiple data platforms at Mode Analytics and ThoughtSpot on DuckDB and served customers such as OpenAI, Lyft, DoorDash. And we share a special love for performance engineering. In the last DataFusion meetup, we shared a little bit more about our work, building a DataFusion extension to read and write DuckLake catalogs. We've been working very closely with the DuckLake team. They've been great collaborators. And in general, DuckDB has been a huge inspiration for us in terms of the developer aesthetics. And in this video, Mark and Pedro share more about our implementation and how our feedback helped shape the standard. The good news is that we have contributed our work to DataFusion Contrib, and we are seeing more companies extend and build upon it. And in this blog recently published by the DuckLake team, you can read more about our experience implementing the DuckLake spec. So I've made a lot of references to DuckLake, but before we go into more details, I don't think I've fully mentioned why DuckLake is of particular interest to Hotdata. So we are now at a stage where we can all see that agents are hungry for data, and it's only going to get more intense. So today, if you think of developers building agents on top of data, they have a couple of options. One is they could go local, deploy DuckDB and SQLite, but very quickly they run into an overhead of versioning and lose visibility and observability. Or they can go to the other extreme and build agents on top of data warehouses like Snowflake, Databricks. But these are infrastructure heavy, walled gardens. They're built for data science teams, not specifically for developers. So then we find that a lot of companies end up building a version of their own. They build their own data platform. And the reason we know this is that we have done this too at Mode and ThoughtSpot. So if you peek into one of these agents that the developer starts to build out, they typically have to give the agent access to tools and certificates and keys specific to the environment, use MCP and APIs to connect into data sources, possibly require vector search and full text search, a catalog, a query engine, some way to capture the logs and metrics, and without realizing they have built a mini lakehouse. And then after laying this foundation, they finally get to the piece of code that they originally wanted to write, which was their unique agentic workflow, which is unique to their business logic. Now, this would probably be okay if it were just a handful of applications and agents. But it quickly becomes unsustainable when you have thousands of these. We are seeing an explosion in agent adoption with evals and IDEs, pipeline jobs, and building the data platform over and over again and repeating the pattern is just not going to be sustainable. And if you peek into these, most of the customers are solving the same problem in terms of how do I persist the data, where do I cache the data, how do I join the data, how do I tune the context window. And we think that these capabilities should be more declarative. And don't take my word for it. This is a screenshot where Okta shares processing trillions of records, again, using their own homegrown system. And we think that this is only going to get worse with the agent adoption. We believe that it would be game-changing if there was a way for these capabilities to be declarative, irrespective of the data source or the query access pattern. And one of the ways to do it would be to let agents and developers request databases on demand without having to worry about building and maintaining the underlying data platform. And that has been a big part of our focus at Hot Data. Now, in order to achieve this simplicity and scale, we needed a reliable way to be able to maintain the state of the databases as well as the frequent updates, and that's where DuckLake fit the bill.
All right. So as Divya mentioned, we previously operated a data platform team with a homegrown data lake. For us, files were stored in object store, CSV and Parquets, and then metadata was kind of scattered around in databases and on disk. And really, it's a familiar story and why a lot of these open source table formats exist, and they really excel at this more consistently than the homegrown approach. I'm sure most people here have heard of Iceberg. DuckLake, maybe a few of you have. Definitely a newer player, but we really like how it innovates by storing metadata in a relational database rather than just on disk. And just to back up for a second, for anyone that's not super sure how these work or what a table format is, the high-level overview is that a table format is just a way to describe the data that backs up the table. So in the most basic sense, it says these tables over here, probably an object store, represent this table. Often they model change over time with snapshots and showing what's been updated, deleted, and changed. And many of these include optimizations to help query planners skip entire sections of data or even the entire files altogether. So at Hot Data, we use DuckLake internally. We really drawn to the simplicity of it and how similar it was to our like homegrown approach, but just bringing in better practices. The way DuckLake works is it stores Parquet files in object store, and then the metadata about that is in relational databases. It can be SQLite, Postgres, or of course DuckDB. Now, a big misconception we run into is folks think DuckLake is for DuckDB only. And this is not true. DuckLake is just a spec, and we run it without DuckDB altogether. So the metadata in the database is spread across 28 different tables, capturing all sorts of things. And then simple queries are done to procure the metadata and then plan the query. For us, DuckLake really takes the complexity from our homegrown solution and just brings in best class features. When we started Hot Data, we were building on DataFusion, but there wasn't a native way to connect to DuckLake, which is why we built the DataFusion DuckLake library Divya just mentioned. This library is free, open source, and donated to the DataFusion Contrib project. It is actively maintained by our team and a growing number of community contributors, and we're always looking for more people. So while many things about DuckLake are really great and we really like it, there's one specific thing that the core DuckLake spec doesn't work well for our data model, and that's multi-catalog support. And just to zoom out a little bit to understand what multi-catalog is, let's just quickly cover the SQL hierarchy. So catalog, schema, table, columns. A catalog contains schemas, contains tables, contains columns. Some engines hide or rename this or kind of make it implicit, but in general, as a generalization, most relational databases are going to have this model somehow. In this context, what we mean by multi-catalog is being able to model multiple catalogs with the same metadata. Today, DuckLake only supports a single implicit catalog. If you need multiple catalogs, you really have two options. You provision a new Postgres database per catalog you need to model, or they do support having separate schemas within the metadata store. But again, you have to create these 28 new tables and then manage them. And this is just too much overhead for us, both from performance of creating those on demand and then ongoing maintenance of keeping those tables up to date. We model each database as a separate catalog. So we need catalog creations to be cheap and fast. So to solve for this, we built an extension to the DuckLake spec. It is in our library today, and it's what we're running in production. It is a superset of the functionality, so it's not a fork of the spec. And it just adds 3 simple tables that allows the core tables to remain untouched and can continue to migrate independently of this extension. But our hope actually is to bring this to core data or to core DuckLake so everyone can use it and remove these join tables. We're in talks with the DuckLake team and have an open discussion in GitHub on the DuckLake repo. If this is a use case that's interesting to you, please chime in because we'd love to consider your use case. So why do we care? Why are we talking about DuckLake multi-catalog? As Divya said, we're obsessed with making databases accessible and fast for every use case, particularly small ephemeral session DBs. To be usable, DB creation has to be cheap and it has to be fast. To show some of this progress, I threw together a very non-scientific, but a benchmark built by Claude yesterday where it integrated with a couple APIs from Hotdata and a few other really good cloud providers. It attempted to discover the optimal settings to give the ideal settings for each platform. And effectively what this is doing is just how many databases can I create in 60 seconds with ideal concurrency and other factors. So yesterday, hitting our APIs, I was creating about 23,000 databases in Hotdata in 60 seconds. And we think this kind of speed is what we need to power the use case, but we actually really are not satisfied with that number. So this is a early preview of functionality we're working on in our labs to greatly improve this performance. Big shout out to Shafiq, one of our senior staff engineers driving this work. While multi-catalog removes a major barrier for spinning up databases quickly, at the end of the day, we're still interfacing with a relational database, which has its own constraints and tuning requirements. And in the previous slide, we're really showing concurrent inserts all trying to happen and getting bottlenecked there. And so here what we're showing is some early batching logic where we batch together the database creates rather than execute them independently. And so what we're doing is transparently grouping the request server side so that they ultimately are inserted in batches into the metadata store while the clients can remain ignorant and don't have to worry about this coordination. Yesterday, this was 650,000 in 60 seconds, but we've actually observed a lot higher. We're also adding support for client-side batching for specific use cases where that makes sense, like agent orchestration. And our goal is to be able to support 1 million databases in under 60 seconds, and we know we're going to hit it. We expect to have a lot more about this in the coming weeks, and we'll share a blog post with our findings and experience. So we're really excited about this. We're excited to bring this kind of scale to DataFusion, and thank you so much.